Write the following quadratics in vertex form. State the vertex and transformation that occurred to each parent function. Well, in order to write this equation in vertex form, by the way, this is in standard form, we need to complete the square. So we're going to start by adding 2 to both sides. And I personally prefer to write 2 plus y. If you want to write y plus 2, it does not make any difference. But when we write it in this format here, what's going to happen next is that we need to add in our box. And notice I added that box on the other side as well. To figure out what goes in this box, we look at the number in front of that. It's 4, including the sign. So it's positive 4 divided by 2 squared. Positive 4 divided by 2 squared. And let's simplify that. 4 divided by 2 is 2 squared. Plus 2 plus y equals x squared plus 4x. Same value over here. 4 divided by 2 is 2 squared. Well, the reason I write it like this is because this number here in this box is helping us complete the square. And complete the square means that we're going to have the same values in both of those parentheses. So x and x, 2 and 2, and this 2 is positive. And we can start simplifying over here on the other side. 2 squared is 4 plus 2 plus y. So 4 plus 2 is 6 plus y. And we can condense over here. Well, when we move the 6 to the other side, we end up with y equals x plus 2 squared minus 6. This is the vertex form. And that format is y equals a times x minus h squared plus k. And what happens here, if you've been working throughout this assignment, you've done a lot of turning points. Change the sign, keep the sign, which means that our transformations are going to be left 2, down 6. Think about what you'd have to do to graph that point, -2, -6. You're going 2 spaces to the left from the origin and 6 spaces down from there.